In this part of episode 3, I want to talk about exponents as they relate to positive and negative numbers. In other words, I want to talk about raising integers to powers. Now, one way to calculate exponents, one way you can always calculate exponents, is just to think about exponents in terms of repeated multiplication. We remember, for example, that if I give you something like negative 2 to the power 4 with an exponent of 4 and a base of minus 2, this notation is telling us to take negative 2 and take 4 copies of negative 2 and then multiply those 4 copies together. And we have just finished talking about how we multiply together multiple copies of negative numbers. First of all, we count the number of minus signs. And here, because we have an exponent of 4, we have 1, 2, 3, 4 negative signs in our product. And 4 is a even number, so our final answer will be positive. We will get a positive final answer. So all I have to do is take 2 times 2 times 2 times 2, multiply the positive versions of these numbers together, and keep the final answer positive in the end. So 2 times 2 times 2 times 2 gives me 16. Positive 16 would be my final answer to this question. Now, if you are working with relatively large numbers, like for example, if someone said raise negative 3 to the power 5, you might prefer to use a calculator to do that expression. So in the calculator, I'm going to type in exactly the same thing that I saw in symbols here. I'm going to type in parentheses, the negative symbol down in the bottom right, 3, close the parentheses. Then I'm going to hit the upper arrow here on the right side, and I'm going to type in 5 for my exponent, and then I'm going to hit enter. And I can see from that I'm going to get an answer of negative 243. And this makes sense because if I'm multiplying together 5 copies of negative 3, then I would get 5 copies of the minus sign from that. And so since I have an odd number of minus signs coming from this odd exponent, I would get a negative final answer from that product. Now, when you're dealing with exponents and negative numbers, there's only one issue that I think you really have to be careful with. And that has to do with how parentheses are used to help us to read expressions that have both negative numbers and exponents in the works. If you have an exponent like 2, by default, exponents only apply to the one symbol directly underneath them. So if I write something like negative 3 to the power 2, if I write it just like this, what this is saying is that only the 3 is raised to the 2. Only the 3 is going to have this exponent applied to it. If you write something like this, the 2 is not being applied to the minus sign. The exponent of 2 is only getting applied to the single symbol 3 directly underneath the 2. So the result of this calculation would be take 2 copies of 3 and multiply those together by PEMDAS. Here's the E in PEMDAS. Calculate the exponent. opposites fall under the M in PEMDAS. So the next thing I would do is -9. So final answer, -9 from this. Now that's very different from if we put parentheses around the -3 and then applied the 2 to that quantity. If you write -3 in parenthesis and apply the 2 to that parenthesis, this is how you communicate that I want to take -3 and raise that to the power 2. So this would be -3 times -3, where now I have two minus signs. And since I have an even number of minus signs, my final answer would be +9. So be really, really careful about that. If you have an exponent on a symbol, but there are no parentheses, the exponent only applies to the one symbol directly under the exponent. It won't extend to cover this minus sign as well. If you want to do the square and include the minus sign, then you have to use parentheses to include the minus sign on that 3. This is true in the calculator as well. In the calculator, if I try and type in, it's only going to apply the exponent to the 3, and so I'll be left with a single minus sign times 9. Versus if I do -3 to the power 2, but the -3 is in parentheses, then from that, I am getting +9 because it's squaring both the 3 and the minus. So just be on the lookout for that. In the final part of episode 3, let's get some practice using the order of operations when integers are involved. So for example, someone asks me to calculate the value of parentheses -3 plus 2 times parentheses -5 minus 1. Now, following PEMDAS, the very first thing that I'm going to do is I'm going to work on these additions and subtractions inside of the parentheses. So the first thing that I'm going to do is I'm going to ask myself, what is -3 plus 2? Well, if I start with a debt of -3, but then I am paid $2, then I can pay off a little bit of that debt, and that leaves me with -1 units of debt. In the back, I have -5 minus 1. So I'm already in bad shape with -5, but then someone comes along and takes an extra unit away from me. So now I'm even worse off than I was before. Now I am down to -6. So now I have the product of -1 and -6. And we've noticed that when you multiply a number by -1, the result is always the opposite of what you started with. So the opposite of -6 would be +6, and +6 would be the result of this calculation. What about this one? Someone says to me, I'm interested in 5 plus -3 all over +3. If I use PEMDAS to calculate this expression, the first thing that I'm going to do is I'm going to complete the calculation on top of the bar because there are hidden parentheses on top of a division bar like this one. Now, if I have 15 units here and I add -3, I remember that adding a negative number is the same thing as subtracting a positive number. So I could think about that as 15 subtract 3 if I want to. Now, if I have 15 objects and I remove 3 of those objects, then I'm down to having only 12 objects. So now I have 12 and I'm dividing them into 3 groups, or I'm dividing them into groups that have 3 objects in them. The result of that division is 4 12 divided among 3 people, each person is getting 4 units. So 4 is my answer to this question. What about this one? Someone says, I'm thinking about 24 divided by 2 minus negative 4. Once again, even though I cannot see parentheses, I understand that there are parentheses in the bottom underneath this division bar. There are hidden parentheses in the top and in the bottom of the division bar. So I'm going to calculate this quantity under the bar first. And once again, for this subtraction, I think I will use the fact that subtracting is the same thing as adding the opposite. So taking away a negative, taking away negative 4, is the same thing in the end as adding a positive 4, 24 over 2 plus 4. Now 2 plus 4 is equal to 6. So here I have 24 divided by 6. And 6 goes into 24 4 times. So I get 4 from this calculation. And what about here? Here I have a pretty complicated expression, negative 4, parentheses, stuff in the exponent, and then after that, plus 8. We remember that with PEMDAS, there are again some hidden parentheses in the exponents. So we should calculate what is happening inside this exponent first. Now, if I have negative 5 to begin with, if I have a debt of 5 units, and then someone pays me $7, I can spend 5 of those dollars to pay off my debt, and then I have $2 left over. So I would have negative 4 in parentheses to the power 2 up there in the exponent. Now the next thing that I'm going to do following PEMDAS is to evaluate what is happening here. What happens if you raise negative 4 to the power 2? In other words, what happens if you take negative 4 and multiply it by itself? Well, 4 times 4 is 16, and since I have an even number of minus signs coming from this even exponent, I would get positive 16 in the end. Positive 16 plus 8. And then from that, positive 16 plus 8 would be 24 units. So those are some example problems using PEMDAS when you have negative numbers around.